All right, that's an active dude, isn't it? So, um, thank you for having me here. It's very nice to be here. And I just learned Labadiana or Diana. All right, Labadiana Vilnius. Sorry. Thanks. So, I know you guys just had lunch. And what normally happens when I have lunch is that I get very tired, and so I want you guys to do a little exercise with me to secure the content of the talk, to secure our communication, because it's all about security nowadays. I want you all to just stand up. Can you please stand up? Security is about discipline. It's about knowing what you have to do. It's about taking risks. It's about taking action. To do this right, I want you all to say hoorah at 3. 1, 2, 3. Hoorah! A little bit louder. Once more. 1, 2, 3. Thank you. All right. Applause for yourself, people. Love it. Love it. Thank you very much. All right. So now we got a little bit of a military team, and I want to get started. All right. So I just want to know a little bit about you guys. And I just noticed I could see you when I stand over here. Who of you is in security? A few, quite some hands. Nice. Who of you is a developer? Many hands. Who of you is a rocking pen tester? Okay. Let's get started. So, a little bit about me. If the ticker works. Okay, I guess I'll be grounded. It's all no, oh, sorry for the technical difficulties. So my name is Jeroen Willemsen. I'm a consultant at Xebia. I'm a security architect, which means I help companies to take security completely integrated, do stuff with that. I'm also a full stack developer, and I can say that because I went into some kernel stuff all the way to front-end funky stuff or whatever is necessary. I have a knack for mobile security. I'm the project leader, or one of the 2 project leaders of the mobile security testing guide project at OWASP, and I really like that. But the thing, of course, about mobile is it doesn't make sense to secure your mobile app if all the stuff behind that is not secured. So that's why I try to, motivate people to do stuff with security. So the goal of this talk is to basically help you on the next step of your security journey, because it's a journey that never ends. And let's take this journey together, shall we? By the way, if you have any questions, use slido.com with the hashtag. You know how it works by now, right? And if you have something really prying, I can't see you. So if you want to ask something directly for a discussion, the front row, you can do this. Rows at the back, sorry. So let's just wait at the end then. All right. So what we're going to talk about today is how you can make a secure pipeline, which obviously involves the security pipeline, and we end with recommendations, because it's a lot of stuff I'll be tossing at you and which you have to take care of. But before we can get anywhere, we have to start with the simple question, why? Why do we bother? Why do we bother about security? Why we should bother is because we get a lot of diamonds where we're working with. It starts for you as a developer with the code you're making. It's something somebody else has put money in, unless it's open source, of course. It's something you put effort in. It's something you want to secure. Next to that's actually the application that you deliver. You don't want that application to be breached or be used for adversarial attacks. You don't want your work to be used for the bad unless you're an awesome exploit writer, but normally developers like to do good in that sense. Then there's of course your users you're trying to protect. They're also part of your diamonds. They're the treasure that you should try to safeguard. Because the moment they start registering and using your application, they're basically trusting upon you guys doing your job well, so that their data stays secure. Then of course the data is another treasure that we want to safeguard. We want to make sure that nobody gets that. And in the end it's the company brand. Whether you're an outsourcing company and you're working for another brand, just make sure that you actually take care of this. All of these are your treasures. Now you might wonder, yeah, I get that. I get why I'm doing my job. Why bother? Where can something go wrong? Well, let's have a trip down application lane. Over here you can see your application, for instance in a container. So you got your app code over there, a bunch of third-party libraries which is running on a runtime. And it's of course very technology agnostic. So in Java this thing can be pretty thick. in JavaScript, this stuff gets pretty thick, and depending on whatever you're going to do, that might be very large or very small. Well, that sounds pretty good, right? But what can possibly go wrong? So, for instance, your application code can contain vulnerabilities, which means that your API is not doing sanitization. When it's getting input or other stuff goes wrong, your libraries might have a lot of vulnerabilities, which will make things less transparent for you and also allow for other exploits. Then your runtime might be configured badly, so you took insecure defaults to your runtime, or you added functionality which you thought was a great idea, but actually landed somewhere else. So nowadays we would say we don't really bother about that because we're using Docker. We're containerizing our applications. So the moment that we containerize it, we shouldn't be hurt anymore, because if you hit one container, you might not hit the other. Well, that's a nice idea. Who of you, by the way, knows how Docker works? Can I see some hands? Who of you knows how the layering in a container works? Okay, there has been an awesome talk about it already, so just double check. I forgot the author. Just go through the schedule, visit this talk through YouTube, and then learn if you couldn't raise your hand, because I think it's important that you understand how the technologies work that you're using. Because the moment you basically have layers, you start basically with the base layer and layers on top, and then end up with your application. Depending on what you're using, the amount of layers might be bigger. If you're using Go, for instance, you can use from scratch containers because you can cross-compile the Go app. But with a Java application, it's going to be a bit harder. So you need more layers on top of it. And then, of course, the question becomes, what's actually inside those layers? Those can have vulnerabilities. Who of you knows Heartbleed, by the way? Okay, given time, I don't have time to explain everything. Guys that didn't know, ask them. It's a wonderful story. And of course, you can have other vulnerabilities in the base layer of your operating system. So your base image might be outdated, have issues with systemd or other things, for instance. Well, that's all fine, of course, because we can say we can isolate the container. In fact, we can run it in high availability mode. We have a bunch of them scheduled over different nodes. So the moment one gets compromised, we're okay. We still got a bunch of others, right? And of course, they're running on top of a Docker runtime. You have the Docker daemon in there and a bunch of other abstraction layers, whatever you're going to need there. But then, of course, what about the insecure configuration? So the guys that just went to the OpenShift talk, if you're using OpenShift, it's wonderful because there's a lot of secure defaults. In Kubernetes, that's not the case always. So bear in mind. And then, of course, there's a bunch of other things that can go wrong. So you thought that your containers weren't privileged, or that you did it well in your operating system or in the other abstraction layers. But actually, there were hooks possible towards the host operating system, just compromising everything. And what about the actual host operating system? Wow, that's a lot that can go wrong just in a few minutes, right? And luckily, there's more, which is funny. I think it's funny because that's my daily job. So it has been quite a few times in the news that keys were leaked or credentials got leaked or a lot of things got dumped. Network compromise, so basically that actually happened to one of my customers, that we did everything very well. We hardened a lot of things in depth, but then we just forgot to just close down the ingress, and everybody from outside could just get there, and then we found out we didn't do everything very well. So your network is important. Then there's your source code. Your source code is important in two different ways. First of all, the stuff that you're working on might contain IP in there, so you want to have it confidential. And it might otherwise leak other issues, but that's a different debate. The other thing is the integrity of the source code. The moment somebody can manipulate that, so for instance, if you're not signing your commits, which many of us aren't doing, then we might end up with actually rewritten commits in that sense, which has side effects, like running a miner in the web browser, which is fun, but maybe not what you intended when you wrote that web app. And what about social engineering? So if you do all the things right, and then still your admin is being called and he has to redeploy and you need to use an external registry because something was very bad with your current Docker registry, what you're going to do? Well, obviously, by now everybody's going to say, no, I'm going to call security. But there's more sweet ways of talking your way through. And then, of course, identity and access management issues in general. So what if you as a developer have too many access rights? Of course, we don't like to talk about this because we want to do this stuff swiftly. I get that. So we'll visit it later in a more positive stage. And then, of course, the cloud hosting configuration. So There was, for instance, a nice talk already by Dave Lewis yesterday, which is Data Breach Barbarians in the throne room. And what I liked about that talk is that he showed that a lot of things have been done securely by default, but at your cloud native provider, you can still override settings with less secure ones. Probably because you're in a haste, or because it was a good idea because somebody else couldn't access it, so you wanted to help him. We want to be helpful. We don't want to, be problematic. But in the end, we end up with a lot of security issues. So then the question becomes what we're going to do with that. So risk officers, compliance people, CISOs often have the feeling that they want to panic because DevOps is fast, we don't get that anymore, we're lag behind. And at the other end, we want to make sure we actually have value together. So the easiest way is to start talking about security checks, right? Let's build in security checks. Let's make sure we pen test everything. Let's make sure we start testing everything. And I think in general that's a good idea, but it may be even better to make sure you do other stuff as well. Because what you end up with is something like this. So we do all the stuff for production, we do testing, we make sure everything is rigid, we make sure everything works, we automate our tests, which we're going to talk about a little bit later. We educated each other to make sure everything is right. But in the end, if the build server gets compromised or the code gets compromised, there's nothing you can do really, because we configured everything as code. So here we go. And that brings me basically to the next step. How do we make a secure pipeline? How do we make this work? So this is a nuclear bunker, which is pretty secure. The doors are very thick. You have to go in the ground quite deeply, and then you can find shelter. And by default, it's all locked and done. So basically, you can't do anything, which, well, let's make sure we don't end up in that direction. A party that tried to be too open is CCleaner. Who of you knows about that story? Okay, quite a few. So basically what happened is that attackers were able to inject additional malware into the CCleaner client by having a compromised continuous delivery pipeline, and that got spread out to customers. It was caught on time, luckily, but it's really an example of that something is wrong. So your pipeline is your production environment. Production is just production, which is great. I mean, we get that, we want to secure that. But you actually got a secondary production, which is your CI/CD environment. And like every production environment, you need to do a couple of things right there. First of all, the monitoring and alerting. Let's make sure you actually know what is happening, or afterwards you can see what has happened. Let's make sure that nobody can do stuff they're not supposed to. Because the moment you actually can do more, and actually can start remove logging, for instance, we're back to square one. Let's make sure that we get our secrets managed. Let's make sure that we actually know where we're at and what's happening. And then, of course, hardening in general. Make sure you have defense in depth. Once you're past one control, you shouldn't have some sort of buttery structure. No, you should still compartmentalize. Make sure everything is secured in there. And next, of course, the stuff we already talked about many times, which I'm not going to talk about, is automation deployment, have immutability to make sure that you don't have to actually SSH to something in production because you deployed something over there, which we'll talk about during monitoring again. Make sure you get easy recovery, because the moment something is broken or you have to fix something, make sure you can easily recover. Have automated configuration and change management. And the most important about that part is that you actually know what is out there. So that the moment that you hear about some vulnerability, the security team doesn't have to run to you like, I don't think we have that, right? No, you actually want to make sure that people can look this up and won't bother you, so you can stay in the zone and do beautiful things. Because if you can do your beautiful stuff, the security people actually have work to do. And let's make sure that we have properly trained teams and security processes. Properly trained teams actually goes further for securing your environment than just making sure how security works. It's also about a culture, to be open, to be vulnerable to each other, to collaborate, to be inclusive, and all of that, well, more social jazz thing. So, because the moment you're not doing that, you might actually start creating internal adversaries, or start having other issues, or start having less quality because you don't know what's happening anymore. So security by general, by the way, is more a people and culture thing first, and the technology I'll spend the rest of the talk about is actually what's next. So if you feel like doing the stuff that we're talking about, make sure that you ask your team, are we okay? Is everything fine? And if that's the case, then we can start moving along. And properly trained teams also means, of course, making sure you know the basics about security, you can do threat modeling and stuff. I'll talk a little bit about that later. But let's just now focus on these 4 highlighted top items. Let's start with monitoring and alerting. Because you will get hacked. That's something you're sure of. But the moment you don't monitor the right things, it's dark. You can't see anything. If you were now here, take all the lights off, let's make this physical. Of course, we're not going to do this exercise. You already stood up for me. I really like that. But the moment that right now all the lights will be turned off and the lights, the highlighting the stairs will be off as well, and you had to evacuate, that's going to be hurtful. You're going to bump into things. You don't know what's happening. And the funny thing is, this is happening in IT all over. Because we're just logging application stuff, but we forget all the other things. Or we do enable them, but we don't do something with it. We're working in the dark, which means that if somebody tries to play with our infrastructure or your application, he can get away with this. Because we don't pay attention. Which brings me to the next step. The moment you enabled all this logging, you still have to listen to it. Because if you don't listen to it, if you don't do the right filtering and alerting, it's just data, which is a great credit card burner in a cloud native environment, although it's pretty cheap. But it will not help you. So make sure you actually start listening for it. Make sure that you know what to look for. And that can be daunting at first, and it's a different slide deck about what type of things you have to think of. And there was a very cool talk just before lunch about honeypots, and it's also a great starting point to learn where you have to listen for. You could do CTFs at your own company with a honeypot and then see what's in the access logs. See what's happening. Try to understand this, and try to mimic this for your own production environment. But there's more, of course. So let's have a look at what we're logging for actually, right? So we got our application in a container. We got a host where this container is running on. We got a bunch of network components and other servicing components. So from the application, you get a bunch of logs, hopefully. If you did the coding well, you'll make sure you audit log the things that you should care of. You're going to log other stuff like application errors, stuff like that, and actually get somewhere. The next, of course, you might have other components in the containers that probably should log something as well the moment that they're activated. So it's important to actually check for them. Then, of course, your host where it's running on. So you might have your audit dlogs, which basically monitor a bunch of files to see if somebody's accessing them and or modifying them. By default, it might not be properly configured. So make sure that once you're having your running host, that you actually do configure these kind of extra things. Because you want to make sure that the moment somebody is touching your password file, that the moment that somebody is touching your configuration files, you're actually getting notified, or you actually have it in a log. The same actually holds for SSH and a bunch of other things. Now the cool thing is, by the way, if you have true immutable infrastructure, you don't need SSH actually that often. You could actually by default not have it at all, which is great, because now you don't have SSH to compromise, which is fun. Next to that, of course, is if you still have it, make sure that actually everything that is gathered there in terms of logging, in terms of things trying to access it, is actually being logged properly. So from your network components, you'll have your firewall logs, you'll have your VPC flow logs in AWS, for instance, and a lot of other things, which are good to analyze and can be forwarded to a SIEM later, as we'll see later on. I think it's important to know that, because even though sometimes attackers won't get past your first line of infrastructure, it's important to at least get a tangible feeling of what's going on, to understand what's happening. And what people often forget is something cloud. So for instance, for AWS, enable CloudTrail. Make sure you know what's happening at the configuration level. If you still have on-prem stuff, which is great, I'm not saying you shouldn't, but make sure that everything that happens over there is logged as well. And not just only checkable by the guys who configure it, but will be at some storage, and that you can make sure that the security team has access to it, or that the security tooling has access to it, so that the moment that somebody is spinning up stuff that shouldn't be there, or somebody's overriding storage access rights, that we get alerted. So in general, there's a bunch of things you can do. Because of the fun talk of syslog and G, I just added that, but it doesn't really matter. The most important thing is that everything gets forwarded. For instance, your host logs can be transported using a bunch of tools like JournalBeat or AuditBeat or LogBeat. Other components can log forward as well. and then you do your analysis over there, and then in the end, you make sure you have some sort of letting service. And I'm not saying that one service is better than the other. I try to make it as agnostic as possible, because the most important thing is that you do alert. Obviously, it's a good idea to make sure that it's parallelly sent to a SIEM as well, so that a security team can analyze it. But what we've learned in the past is that, especially if you transfer to cloud native, whether it's lift and shift or something else, that the amount of data that actually comes from the new components in terms of logging is way more than the security team or the SIEM team ever expected there to be. So it might be a good idea to have a conversation with them before you start flushing a lot of data through that pipe to them and hope they make up something. And again, it's very important that the different teams that will basically support these different components get together, actually make it work together, so that the moment you want to make rules for the SIEM, you actually know what rules are necessary to start detecting certain patterns, what we should care about. And there's a lot of solutions that say you don't have to, which I think is a lie. I mean, AI is a beautiful promise, but we're not there yet. Especially you guys who make the application, the developers, you know what is odd behavior. And otherwise your quality assistant basically, so the new Q&A tester, can help you to redefine that, what is odd behavior. So the moment that the security team knows that as well, then together you can actually make this work. So then you know what to alert from. Next is make sure that you always write it to a write once, read many storage, and make sure that you sign the logs and stuff like that, so that nobody can tamper with it later. Because the first thing an attacker will try to do the moment he enters your infrastructure or your supporting infrastructure is try to tamper the logs. So he can clean his trail and we know nothing. Then we're lost again. So that's about logging. And of course there's more to it. There's Prometheus, so the moment that you basically get odd loads or an odd amount of 500s or something else, like stuff that has been talked about in the previous talks, it's good to be alerted to see what's happening. And if you want to make sure you actually get the right sources and the right metrics, just get together with the security team at your company. If you don't have one, I'm pretty sure that there's other conferences or other talks or blogs or whatever that can get you started. Just make sure you start so that you know what to look for and you stop being blind. So that's about being blind. The next thing once you actually see is how you respond on it. And there's a very nice talk I think you all should watch if you're interested in security and now that you finally have a vision. It's a talk by Nick Drage. It's Lessons from the Legion, the Ovals Benelux remix. It's a very nice show the way he plays it. But the most important thing you should get from it is that security is not a game of chess. It's not a game of golf. It's similar to American football. You have to be in there. The moment you get attacked, you have to move. Yeah, shutting down or watching, that's all great. But it's more important to divert attackers. If they're in a host, make sure that the host moves somewhere else. If there is something else, make sure that that no longer is connected to your database. Because the jewels we talked about are the ones we're trying to protect. And we can't do that if we just, like golf, play along and let them just play that ball and go somewhere. So, identity access management. Developers are your production users of the pipeline. So if you have a bad example, Facebook or Gmail account or whatever, it will be very odd, to say the least, if somebody else can do the exact same things with a different account and then impersonate you, right? I hope I'm still the same Jeroen Willemsen at any social media and that you cannot act like me. And this is not an invitation to hack me, just to make sure. But basically, you want to make sure that that doesn't override. The same should happen at your CI/CD pipeline. Make sure that your developers aren't all forced to use an MPA, but you can identify them and that it's very clear who's doing what. An ops engineer or platform teams or SRE teams are your admins, so treat them as such. If a developer really needs fully powerful admin rights, obviously that can happen during, that something goes really, really wrong. But if that's by default, it's going to be very hard to track changes and to see what's happening. A good example over here is, for instance, Bob at a company. We already use some security automation. So Bob has a personal account for Defect Dojo, which is a vulnerability manager, a non-personal account for Jenkins, a non-personal account for OpenVAS to do some security checking, and a personal account for OpenVPN to connect somewhere. Now Bob gets sacked, because Bob seemed to be not a very nice person. So how are you going to make sure that Bob cannot start Metasploit his ass off and actually start penetrating stuff and just use open source exploits to get further? How do you make sure that Bob can't use that MPA anymore? Well, that can be a bit of tough love. For that, you have to do at least the following things. Make sure you have a central identity store where everything is regulated towards. So that means something like an Active Directory. Don't spread the single username and password and put it in Confluence like many other companies did. Don't have a single MPA for something that everybody uses. Make sure you federate. And you can integrate that with ADFS or Auth0, whatever is necessary to make sure that you can block everything at once. Make sure you have airbag in place whenever necessary. And verify always. Should a user still have these roles if his function changes? Are all actions logged at least? Because if somebody needs to be overpowerful, let's at least make sure that everything he does is being logged correctly. So the moment something odd happens, the right people are informed. And do we get privilege alerts, for instance, when you have privileged actions? Do you have segregation of duties, so nobody is in complete control? And is the 4 eyes principle in place? So for instance, do you use protector branches to make sure nobody can just commit anything wildly to master and deploy immediately? And is multi-factor authentication enabled for something that's really critical, like showing you are you at the AD, for instance? Next is secret management. So in secret management, there's a bunch of different things you can do here. These are a bunch of cloud-native solutions, and probably by now, given the different talks, you all know HashiCorp Vault. Again, have proper access control, have proper audit logging. Don't reuse secrets. That's very important, because secrets will get compromised. It's a matter of fact. And make sure you integrate with the consumer of the secret, not its environment. Of course, it's great if you start with rotating secrets and using environment variables, but it's better that the process that consumes these variables actually is able to get them. Because otherwise, if your environment gets compromised, you're back at square zero. And rotate the secret. So HashiCorp Vault is very nice for that, and you can make it very fast. In a few other cases, like the other components that I mentioned here, you have to do manual work, but it's worth it. So a security pipeline. So obviously now it's getting a little bit of meta, because we said we want to harden our pipeline components. Well, our pipeline components, if you use immutable infrastructure, should be created by your own pipeline. So that's why I figured it might be a good idea to remind you about security automation in general. Just to make sure, who of you is already doing security automation? There's 2, 3, okay. For those who don't, start, and you'll figure out why. So this is a normal pipeline. I'm not going to jump into all the details. So basically, you start in Git where the technical stuff happens. You start pulling and merging. You build your assets. You do your unit testing, your end-to-end testing. If something is all right, you start storing it. You deploy it to dev, and it's ready for validation. Obviously, you can have dozens of different alternatives to this, but this is basically where it mostly drills down to. So you can start simple by just checking dependencies. Just check your app code, see what's in there, see what you've added. And be aware that sometimes if you do stuff like Go, it might be that libraries added are not in Go, but are in C++ or whatever. So see what's happening there. Make sure you get feedback fast. So the moment you start basically building, make sure you have your third-party checkers over there. Already there was a great talk about the Azure Security Center, which also had, in that talk there was a showdown on how this can be done automatically by the platform. But in most other cases, that's not often the case. So therefore, I don't want you to start automating and do wild stuff. Start simple. And I really mean simple. Take your code, use a free app like Retire for JavaScript, or the OAuth dependency checker for a lot of other languages, or curl towards one of the open source feeds given the dependencies that you see, and just start manually. Just run the tools. See what's out there. Why? Because you'll get a lot of different data. So you might have a lot of false positives, for instance, because these tools aren't perfect. They might identify some of your components being as something that's not entirely the case. For instance, if you have who of you is a Java developer? A few. Who of you is a Spring developer? Good. So if you use the OAuth dependency checker, for instance, on a Spring Boot application, then sometimes he gets messy about the libraries being in use. So he will say, there's a big vulnerability, you have to update this. But you're using an entire different package than the one actually supported there, or stated there. So then it's important to start suppress that, as in, that's not what I'm using. It could also be the case that there's a vulnerability noted that's not even related to what you're doing. So when you start doing this, if you're not sure what the vulnerability means, ask a security guy or start Googling. You'll find the answer pretty soon. Because sometimes it might be that there's a vulnerability that's not even very very bad in the sense of even if you exploit it, nothing serious will happen. But most cases, it's good to just check and see if you can use an updated version of the library or, schedule an upgrade. And then when you start automate, making sure that when you have duplicates or you have a lot of false positives, you can consider a vulnerability manager like Defect Dojo, or you can start having local suppression files depending on what you want. And make sure you don't fail or notify until you did a proper first cleanup. So first do all the manual stuff, then start to automate. Because otherwise people will be very annoyed, to say the least. Or at least I know from many of my customers that when we start introducing this, developers got very annoyed by the amount of stuff that wasn't there or wasn't necessary because, for instance, they were still checking the test libraries. And yeah, Mocha.js had issues in the past. But it's not in production, and it's also run in such an isolation that you might say it's not required to look at them. And so are many other issues. Last thing that's really important, cache your vulnerability feeds. Because you're using open source feeds, and those servers don't have power forever, or bandwidth at infinitum, so make sure you do something in there. And then, if you still need a commercial tool, so if you did all of this stuff, and you see you're missing a lot out, then start testing before you buy. In many cases, it might be that you don't need one, depending on the libraries and language that you're using. And it really varies per language and per runtime that you're working with, or per framework. So what about the application sources? For static code analysis, that's a great idea, because then we can, run through them. There's actually a nice difference in there. So part of the static code analysis is about quality tooling, which is about JS hint, JS lint, check style, stuff like that. CPP Finder is more of a static tool already, but I think it's important to always have those quality tools. Why? Because you should create readable code that has one style. Because the moment we're trying to review it for security bugs, you're making this holy one-liner nobody understands, other than maintainability issues, you might end up in security issues nobody will ever understand. So make sure you do your quality tooling first. And the funny thing is, the security people never really cared about that until we were finally involved in the DevOps train, and we call it SecDevOps or DevSecOps or whatever you want to. And at that point in time, we finally realized if you guys create beautiful code, which is very well readable and very well isolated, it becomes much easier to test. So always do this. The next is, of course, the actual security tooling. So who of you knows these brands? The check marks, the Fortify. Just a few hands. So these are awesome big tools that can work in certain languages given certain frameworks, but in many times they don't work at all. And it's best to find out the hard way. Now there was a very nice talk by Zane, which I think you should attend. That was yesterday, so you have to watch a YouTube movie, which actually does a few nice catches on which you should think of here. So you can have your static code analysis here, which can be an easy grab or something else, depending on what you want. But make sure that you actually do proper quality checking during your build phase as well. So let's do some dynamic analysis. That will be the next step. So for dynamic analysis, it's easier that you first deployed something, otherwise you can't do anything. Again, start simple, start manual. And if it's effective, then automate. It really depends on your app whether it will work or not. And then you can use stuff like Zap. And I think given time, it's good to just go through the basic ideas over there. Just make sure you test small parts, you authenticate your application with Zap properly so that Zap can actually scan for the authenticated parts, because that's where most of the issues are. But only do this when you find this useful. And then, of course, when do you know when you have a hardened container? So when do you know that you are at something? So for this, it's best to have a step. So over there, you can either go for layer by stuff like Claire, Anchor as your container registry or Docker Hub, and they will tell you what's going wrong over there. The problem with this is, of course, that the moment you have a layer above that negates the previous security issue, you actually get a false positive. But you won't know unless you know what happens in the other layers. So the alternative would be to use Nessus or OpenFast to do dynamic scanning. And often it's up to you to just start testing to see what works best for you. And then, of course, you can see if somebody actually adheres to the proper policies as a unit. So you can use OpenSCAP or Linus or Inspect, depending on the container type you're using or the base OS. And then you can run on. The same thing, of course, happens for your infrastructure pipeline. So I guess the SRE people in the room and the infrastructure automated people know what's happening here. And given time, we'll just skip through. But it's actually similar to a container. So again, start scanning them. See if you got some vulnerabilities in there. More importantly, see if you actually did the best practices there in terms of hardening. Now, the Azure Security Center, which was presented yesterday, also has nice features in there. So if you're on Azure Stack, start playing with it. And otherwise, use these tools to see how well you're configured. So all you have to do, make sure you verify first before you tag and push an image. And the same thing happens for your base image. So at some point, your golden image that you're going to reuse for your infrastructure will be stable. Now we can put it all together in one big pipeline, which is an awesome idea. Because what will happen is, well, the 6 hours, that's not really weird if you did all the security checks. So the balance you have to find actually is to make sure you test enough, but not too many, because otherwise it takes forever. That's why I'm saying always have different pipelines to fix this. And the automation won't fix everything, because you still need manual verification. And it's cool if you guys can do some security trainings or whatever you need to be able to do it yourself as developers or as Q&A specialists. Because scans won't find everything, which also brings me to something else. Because it might be that you won't find stuff. So start doing threat modeling and create evil user stories. And if you have trouble understanding what it is exactly, come to the Q&A corner or just visit the OWASP wiki, and there everything is nicely explained on what you can do there. So you get a feeling basically of what could possibly go wrong. And based on that, you can start creating automated tests yourself, so you can start checking whether that vulnerability actually exists. The same holds for when you have a pen test, that you can check later on with an actual automated test whether that pen test finding still exists. That's a lot of stuff. So let's see where should you start? What should we do? What are our next steps? The first one is start small. Begin with your infrastructure hardening. Make sure you've done that well first, and then care about the apps. Automate as much as you can. I want to take a next step, take a risk-based decisions. Really see what's more important. Will it block you to go live fast? In that case, don't. But first try something else, because making sure you have something to sell is more important than sell something securely, obviously. So make sure you find a balance there. Protect your pipeline like a production environment. Prepare to learn from your mistakes. You will get hacked, and the security guys will not like it. And you probably will be hit in your pride as well. That's fine. Just make sure that you're ready not to be hacked the same way the next time. And never stop improving. This is a journey which is endless. As your development journey is endless, as everything else is endless. Everybody evolves, so should you. And measure the effectiveness and cost. That's a lot of things. So just take it up, think about it, and I hope I inspired you to take your next step in your security journey. Do you have any questions?
Thank you, Jeroen, for your take on security.